Going to talk about acceleration in the standpoint of free fall. We're going to throw an object up and then we're going to catch it as it comes down. So we're going to have a flat surface and we're going to toss a tennis ball directly up. So here's your flat surface and you've got a tennis ball in your hand. And of course, if it's at rest, you're going to have to exert a force on it and accelerate it. And let's say you accelerate it up to a speed of 40 meters per second. So now when it leaves your hand, the ball has an initial velocity of 40 meters per second. As the ball goes up, we're going to analyze its motion. So as it goes up, you got to remember that it is fighting against the acceleration of gravity. The acceleration of gravity is negative 9.81 meters per second squared. Actually, just to keep the math easy, I'm going to use negative 10 meters per second squared. So depending on your teacher or what assignment you're working on, make sure you use your number appropriately. If you don't have a calculator, then go ahead and use 10 meters per second squared. But if you're in a lab environment or an experiment, make sure you use negative 9.81 meters per second squared. Or if you're in a web assignment or something that doesn't appreciate rounding numbers, make sure you use negative 9.81. But for now, we're just going to use negative 10 meters per second squared. So the question is, what does negative 10 meters per second squared actually mean? Well, it means that as this object goes up in the air, its speed is going to be changing by 10 meters per second every second. So as this object goes up into the air, and it's fighting against the acceleration of gravity, then it's going to be slowing down by 10 meters per second every second. So this is its speed, its velocity. And it's going to slow down by 10 meters per second every second because it's fighting against a negative acceleration as it goes up. So that means as it goes up, it's going to slow down. And then at the highest point, it's going to be at 0 because it can't get any slower than 0. And then finally, it's going to come back down. And as it comes back down, it's going to speed up because it's going to go in the same direction as gravity. Gravity always is impacting the ball. It's always present, and it's always pointing downwards. So as the ball goes up, it slows down. As it comes down, it speeds up, and it's going to slow down and speed up at the same rate. So as it goes up, it's going to slow down by 10 meters per second every second. And as the ball comes back down, it's going to speed up by 10 meters per second every second. So let's just go ahead and work this problem out. This means that after 1 second, when the ball gets to this point, let's say this is 1 second later, 1 second later, if somebody asks you how fast the ball is going, you'll simply say, well, it was at 40 meters per second and it's slowing down because there's a negative 10 meters per second squared acceleration against it. So now the velocity of this ball is going to be 30 meters per second. And then as the ball goes up a little bit higher, 1 more second later, the velocity is going to be 20 meters per second. So these are all 1 second apart. And then 1 more second later, the velocity is going to diminish to 10 meters per second. So a couple of things I want you to notice. First of all, I want you to notice that the arrows are becoming smaller because velocity is a vector which has a magnitude and a direction. Magnitude just means number. Direction means, well, up, down, right, left. And you should also draw it somewhat to scale. So the 40 meters per second arrow should be larger than the 30 meters per second arrow, which should be larger than the 20 meters per second arrow. The other thing I also want you to notice is that the distance that's covered in the first second is greater than the distance that's covered in the second second. And that distance is greater than the distance covered in the third second. Well, because it's traveling faster in the first second than it is in the second second. And it's traveling faster in the second second than it is in the third second. So keep that in mind. You should always draw your diagram somewhat to scale. And so finally, 1 more second later, the ball is going to diminish its speed from 10 meters per second to 0 meters per second. Now there is always, even though the velocity is 0 here, the acceleration of gravity is negative 10 meters per second squared over here. Because now gravity can't slow you down anymore because it's taking you from 10 meters per second to 0. So it can't slow you down any more than 0 because the ball has come to a rest at that time. So what gravity is doing at the highest point, it's changing the ball's direction. And so you'll notice that right after the ball reaches the highest point, its direction does change because it starts coming down. And as it comes down, the exact opposite starts happening. And I'm going to draw the downwards motion towards the right over here in a different color because just to so you can see it clearly. But remember, when this is actually happening, the ball goes up and it's going to come back down, straight down exactly on the same path as it went up. there's nothing pushing it to the right or left, then it's going to go straight up and come straight down. It's going to be very symmetrical. But for today, I'm just going to draw the downwards motion here on the right. So we're going to start off by saying 0 meters per second at the highest point, and then 1 second later, the ball is going to be traveling at negative 10 meters per second. So up here at the highest point, it's traveling at 0 meters per second. I'm sorry I drew an arrow there. There shouldn't be an arrow because it's at a rest. 1 second later, it has increased its speed to negative 10 meters per second. Because now it's coming down. It's going with gravity now. So it's going to speed up by 10 meters per second every second. 1 more second later, the ball has a speed of negative 20 meters per second. And another second later, this will continue to happen. So 1 more second later, and then another second later, the ball is going to have a speed of 30 meters per second, negative 30 meters per second. Let me write that meter. And then finally, 1 more second later, so that's 1 more second, and then finally, the ball is going to reach a speed of 40, negative 40 meters per second. You should realize that, and even though I didn't draw it as well as should have, this point should be drawn directly at the same place as this. They should be identical. These two should be matching up with each other. These two should be matching up with each other. These two should be matching up with each other. And these two should be matching up with each other. Because it's identical, it's symmetrical. As it goes up, it's going to come down. Whatever gravity took away from you going up, gravity is going to give it right back to you as you come down. So this should have been drawn a little bit lower so that it matches up with this point right here. So they're all going to be symmetrical. So if you look at this problem conceptually, and somebody asks you, if you throw a ball up at 40 meters per second, how long does it take to go up and come back down? You'll simply say, okay, going up 1, 2, 3, 4 seconds, coming down 5, 6, 7, 8 seconds. So you'll say if you throw it up at 40 meters per second, it's going to take 8 seconds to come right back down to the same position it started off. If somebody asks you, how long does it take to go up? You'll say, oh, to go up, 4 seconds. If somebody asks you, okay, at the highest point from there coming down, how long will it take you? Say, oh, 4 seconds. So you can look at this conceptually. You can break it up in halves, going up and coming down, or all at once. But you can also use your kinematics equation, because if somebody says to you, how much time does it take the ball to go up and come down, and you can use your kinematics equation, you'll say, okay, to go up and come down means that the initial velocity of the ball was 40 meters per second. You're going to say that the initial velocity of that ball is 40 meters per second. And that velocity is referring to this right here. And if the question said, how long does it take to go up and come back down, then the final velocity coming down is negative 40. And what's one other thing you know when the ball goes up and comes down? You know the acceleration. What is the acceleration? This is the acceleration, negative 10 meters per second squared. You can write it as A, you can write it as G, whatever you prefer. Negative 10 meters per second squared. This is a negative. And the question originally was, how much time does it take to go up and come down? So they're asking you for time. So how would you solve this? You'd simply use your kinematics equation. Acceleration is equal to final velocity minus initial velocity over time. This is final velocity minus initial velocity over time. You'd rearrange this equation for time. Time is equal to final velocity minus initial velocity over acceleration. What are you going to plug in for your final velocity? You're going to plug in negative 40. What are you going to plug in for your initial velocity? You're going to plug in 40. What are you going to plug in for your acceleration? Negative 10. So simply this will look like this. Negative 40 meters per second minus 40 meters per second divided by negative 10 meters per second squared. This is negative 10 meters per second squared. So negative 40 minus 40 is negative 80. Negative 80 divided by negative 10 is 8 seconds. And that was the answer that we came up conceptually, because the original question was how long does it take to go up and come down? So it takes 4 seconds to go up, 4 to come down. So that's 8 seconds, and that matches up with our answer conceptual, our answer done using our kinematics equations. And if somebody, like I said, if somebody asks you how much time it takes to go up, you can do it conceptually, 4 seconds. Or if you want to use a kinematics equation, you can use your kinematics equation the same way we just used it. But if someone is asking you just for the time to go up, then for the initial velocity, you're still going to use 40 meters per second. The only change you're going to make is for the final velocity, because to go up means you're stopping right here. Right here means your final velocity is 0. So, when you come back down to your equation, to find the time, for final velocity, you're going to plug in 0. For initial velocity, you're going to plug in 40. And for acceleration, you're going to plug in negative 10. Negative 10 meters per second squared. So negative 40 divided by negative 10 is 4 seconds. So this was a quick demonstration about objects in free fall and how you can work the problem out conceptually and how you can work it out using kinematics equations. The most important thing I just wanted you to take away from this was, what does gravity mean? It's a negative 10 meters per second squared or negative 9.81 meters per second squared. It means that as you go up, you're slowing down by this much every second. By this much, your speed is decreasing. Or when you're coming downwards, then your speed is increasing by this much every second. So hopefully this video was somewhat helpful when it comes to using acceleration, understanding acceleration, and using your kinematics equation.